This is a video on rational coding. Now this can be used for general coding of data, unlike those other methods, some of which can be used for audio, video, and some of which for transmission across a network. This is for plain coding of data. It is, as you can guess, it is based on generating all possible proper fractions of the form p by q, where p and q are in the lowest terms. So it is based on generating all proper fractions between 0 and 1, which are always in their lowest terms. So this one came about. What happened was, I was trying to find if p by q and r by s are any two fractions, not necessarily in their lowest terms. Is there a way of generating some form of an intermediate fraction? So any other way, generally we take the half of this middle point between this, but so what it turns out that if you p plus r by q plus s is always an intermediate fraction. Now, so what happens, I discovered, was now the set of all proper fractions between 0 and 1, always in their lowest terms, is generated as a complete perfect ordered binary tree as follows. We start off with 0 by 1 here and 1 by 1 here. Okay, now add the two. 0 plus 1 by 1 plus 1 will be 1 by 2. Now its predecessor is this and its successor is this. So here we go, 0 plus 1 by 2 plus 1 is 1 by 3. Its successor, 1 plus 1 by 2 plus 1 will be 2 by 3. Now its predecessor, 1 plus 4 by 1, this will be 1 by 4. Its successor is this, 2 by 5. Its predecessor is this, 3 by 5. Its successor is this, 3 by 4. Okay, this is the third level. So next level, again, it may not fit in this. So predecessor is this, you will have 1 by 5, 2 by 7, then you will have 3 by 8 and 3 by 7. 3 plus 1 is 4, 4 by 7. 3 plus 2 is 5 by 8. Then 3 plus 2 is 5 by 7 and 4 by 5. Like this you can keep generating. What you notice here, all of them will always be in their lowest terms and there will be proper fractions. So all rational numbers between 0 and proper fractions can be generated as a tree like this. So the general, you can say, a statement or a theorem is this, the observation is this. Okay, so if p by q, it is easily provable. I shall not take the time to prove it here. It is provable by contradiction, by the method of contradiction. If p by q and r by s are any two proper fractions in their lowest terms, that meaning GCD of p comma q equal to GCD of r comma s equal to 1, then the proper fraction p plus r equal to 1. And also furthermore, you see GCD of p comma r equal to GCD of q comma s is also should also be equal to 1. If the GCD of these and these are also 1, then the proper fraction p plus r by q plus s is an intermediate proper fraction which lies between p by q and r by s. This is the general statement, or you can call it as a general theory. So now the use of, so the entire set of rational numbers is generatable as a tree. So for given any data file, you just have to descend along that tree to that particular node, which for that particular size of block of information that you have, it will come to a very small note, only the node number. Since it's perfectly denumerable, you can take that size of the tree up to the size of the length of the machine word. So so the number of bits of the machine word, and come to the lowest fraction. Then again what you have to do is just take for the next word, take that proper fraction and either its predecessor or its successor, one of the two, and note which one you are taking, and again descend for the next word. Then again for that, again you can take like that, you can do it'll. So the size will be small. You can heighten or increase the size of the efficiency of this rational coding, again by noting that if you have take a number which is always less than 2 power, you only have to code the rational fraction for l dash. M equal to 2 power l dash is mapped to s equal to 2 power l. You only have to code the between. So since also if you have 1 plus 1 whole power l dash, for this particular one, again you can code only for this one. So you can either code the base alone, or you can code only the exponent alone, or you can combine both the base and the exponent and code both of them together. So that way efficiency will keep increasing. Once you so the compactness of the code will only keep increasing this way. Furthermore, you cannot take any base you want. B power l dash, you can take any base, because if you take b power l dash, again you will have a value d which lies between, such that a number will lie between d power l dash less than equal to n less than d plus 1 power l dash. Again 1 comes here, so you just have to note d and again code only 1. So whichever turns out to be shorter, however you can code it. So there are many ways of improving upon it. So that is that general statement is that. So you can prove it. Actually it is easily provable by the method of contradiction. It will take some time to do it, but you can figure it out. It's easily done. Now so this is the basic. Now we know that the entire, so this also means that we know that every binary tree, if it is finite, has a unique predecessor and successor. Now the set of integers is again a complete binary tree, right? You can always generate an infinite complete binary tree of integers. Now integers we know has a unique predecessor and successor. For instance, you can just, if you generate this tree of all up to n integers here, then you just have to generate another tree here and tag the middle, add this thing and tag the middle here, whose counterparts are here, and put the middle number there. Then again you can generate integers that are there and tag. So the infinite integers is also generatable as a tree, but see, it must be built up from bottom up like this. So this tells us that not if a complete set, if an infinite set is denumerable as a tree and it is countable, it is always countable, but it doesn't mean that it is always finite. It can be countably infinite also. But it can be also have a unique predecessor and a successor. In the case, depending on how it is. So how you traverse a tree also matters. Whether you traverse a tree, visit the node first left and then center and then right, or whether you visit left and then right and then center, or whether you left center and then left and then right. All of these, when you organize information in a particular tree kind of fashion and choose to visit the tree traverse the tree in a particular fashion, so how you choose to traverse matters a lot to the end outcome. So this is basically rational coding, which can be used for coding large amounts of information.